Assalamualaikum warahmatullahi wabarakatuh, and good day everyone. So I am Dr. Siti Nora Puja from School of Civil Engineering UKM. So let's continue our soil stresses chapter. So today we will cover the vertical stress of the soil. Vertical stress of soil. So in order to estimate the stress that increase due to the external loading, so one needs to know types of the loading and also the shapes of the loading. So we have four to five different methods available. So first one, I would like to show the uniform load for simple method. Simple method 2 to 1 ratio. So we can see here this is a rectangular footing. So it has a B value and also L value with a depth of Z. So we interested to know at Z location how much the vertical stress of Z. Vertical stress of Z. So by using the 2 to 1 methods, just fill up the equation. So the equation is generated due to the 2 to 1 ratio. So as long we know the P value, we know the V, L, and the estimated Z that we want to know. So we can calculate the effective the vertical stress. So let's say in this example, we have a rectangular footing for 3 times 4 meter that carrying a column load of 1,500 kilonewton. So determine the vertical stress of 2 meter using the simple method. So easily just fill up the equations with the 105,000 kilonewton. B is 3, L is 4, Z is 2. So you can easily get the 50 kilonewton per meter cube. Another exercise, you can try this one, but bear in mind, this is in the stress form. So make sure that the P part you need to times with the B and L due to the stress unit. Okay, and in these questions, asking for the vertical stress at E at two different groundwater conditions with the two different groundwater conditions. One is at the ground surface, another one is above the ground surface about 1.5 meter maybe because the site having a flood. Okay, similarly, exercise 2 also wants to define the vertical stress at point E. So I hope you still remember how to define gamma for every stress of every layer and combine the with the loading given, so you can get the vertical stress value at E. Okay, next, the second method is using the uniform load of pedal. So similarly, you have a rectangular uniform load with the size B times L, width times the length, and you're interested to obtain the vertical stress at Z depth. So Fedem introduced the influence factor, and in order to get the influence factor, one need to define the M and also N first. So by dividing the B over Z and also L over the Z, the depth, so you can get the M and N. So what you want to do is to read the N value here and matching with the M value here. So let's say we have N of 1 and M of 3. So you get the I value straight to here. So above 0.08 of influence factor. And from the influence factor, you easily times with the P of the uniform load, and you get the vertical stress at the depth of Z. So this is one example of the feather method. So you are given 3 times 4 meter of the uniform load with the 200 kilopascal. So this kilopascal means kilonewton per meter square. And then you interested to know the vertical stress of that 2 meter. First, at the edge of the foundation, here at the E, and another one at the center of foundation, point of C. So let's solve for the E first. Okay. So in fathom, if you noted the figure given in the graph, okay, the first principle that fathom outlined from his method is the stress increase is to be determined. Any stress increase that wants to be determined must be situated below one of the corners of the rectangular loop. Either here or here, but one of the corner must situated one of the corner at the of the rectangular loop. So, if we want to define E at the edge of the rectangular, so this is not corner of the rectangular. So what we have to do, we design the shape into, we divide the shape into two rectangular. So we have a corner of first rectangular and another corner of second rectangular. So means um, we will define stress of E vertical at 2 3 times influence factor. 2 times because two rectangular, first rectangular and also second rectangular. So let's try. So the shorter length of the rectangular now for the first for one of the rectangular become the 2 meter here and also 2 meter here. So this is B. And of course the other side is L equal 3 meter. So similarly, let's say for C, for the center of the foundation, so as the center of foundation is in the middle of the square, so we need to split the square into or the square or rectangular into 4 different parts. 4 different parts. So you will have 1, 2, 3, 4. So, so you have 1, 2, 3, 4, and you have C here, C here, C here, and C here. So you actually want to define 4 times of rectangular. So P times I. And the P value is still 200. Similarly here, the P value is 200. But the M and N for here and here is different because now it is also become the L also 1.5 and B is 2. I think this one become L, this one become B for this case. Okay, let's see the solution. In here B is equal to 2, L equal to 3 for the rectangular that divide into 2 parts, right? For the H1. Okay, B is 2, L is 3. So we got the M is 1 and also N is 1.5. So the I is 0.195. And from the calculation, as we mentioned just now, we have two rectangular for this point E. So we got the final state of vertical stress is 78 kilonewton. And next for point C, so because we have four different rectangular, so, and we got the I value of 0.165, so that's why we got the vertical stress of 132 kilonewton per meter square. Okay, so this is another exercise of feather method. Okay, so this time, determine the stress increase at the respective point of A, B, and I for the depth of 5 meter from the ground surface. So the Z is 5 meter. And I assume the I is at the middle of the box. So I think this is 5 meter divided into 10 meter divided 2. So, and this is 15 meter from the corner. And for B, so 10 meter from the right side. A is outside from the foundation. So we have foundation with the 100 kilopascal and also 50 kilopascal. So how do you want to solve? Okay, so usually I suggest to do the easy first, the easier one. So from my point of view, the A might be the easiest one because it is at the corner. However, the corner is the corner is lies outside from the foundation. So how do you want to define A? So you might try by yourself, but the theory is you do a bigger rectangular first, and then minus the short one, the below one, rectangular, the length in the longer manner, and then you adding again the 50 kilopascal, and finally you minus again this box only. Okay, one of the feather method principle is every time you want to define the I, means you want to take the M and N value, means you want to take the B and Z value. So you have to make sure that the B and L is defined from the point that we interested to calculate. From the point that it is interested to calculate. So let's say, so as I mentioned before, how to solve for A. So the first one is, this is the B, this is the L. And then another one is, this is the rectangular. The second one you have to minus it. So this is the B, this is the L. The third step, you want to adding the 50 kilopascal. So this is the B, this is the L. But this is a 0, doesn't have any kilopascal, 0 kilopascal. So that's why you minus this is a B, and this is an L. And finally, you check again that you choose for the biggest one, you have a 100 kilopascal. For the rectangular belows, times and plus, minus plus and minus again, you calculate for 50 kilopascal. So I think that's all. You can also carry out to do exercise number 2 for feather. And the rest of the slide you can also study by yourself. So this is example of other type of load and also the method. Okay, that's all I think. Assalamualaikum warahmatullahi wabarakatuh.